channel Knowledge of, and subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your physics class 11, that is if part 1, which we have to discuss here. That's been class 4, which we have to discuss here. And lastly we had done your type class 3, where we had started with unit 1, which has been the physical world, where we had done many of the topics related to it, which is we had done about the physics and the scopes and excitements of physics, as well as we had done your which has been the scope and excitements of physics, as well as we had done your about the hypothesis, axioms, and models, physics, technology, and that society, and the major contributions with the name and the country of the origin. And we had, in the last started, we had started with the link between the technology and the physics, and fundamental forces in nature we had discussed here. But before start continuing with this, it's a huge request to all the viewers to please go ahead with like, share, and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. But before starting with this, that we have discussed about Albert Einstein. About Albert Einstein, which is from 1879 to 1955. Now for that, Albert Einstein here, that Albert Einstein, born in Ulm, and that has been in Germany in 1879, is universally that regarded as one of the greatest physicists of all the time, and his astonishing scientific career began with the publications of the three-part breaking paper in 1905. In the first paper, he introduces the notions of light quanta, that now known called as photons, and used in it to explain the feature of photoelectric effect, and that has been classified a wave, classical wave theory of the radiation that could not account for. And in the second paper, he developed a theory of Brownian motion that was confirmed experimentally a few years later, and provided a convincing evidence of the atomic pictures of matter. In the third paper, that gave birth to the special theory of the relativity that made Einstein a legend. It is known in his own lifetime. In the next decade, he explored the consequences of the new theory, which included, among other things, and the mass energy that equivalence in the Schrödinger and the famous equation, which is equals to mc square. He also created the general versions of relativity, and that the general theory of the relativity, which has been the modern theory of the gravitation as well. And some of the Einstein, that is, we have for the same, that has been the Einstein most significant later contributions, that are the notions of symptom-related emissions, and introduced is an alternative derivation here. So for the same, it will be that some of the Einstein's most significant later contributions, that are the notions of stimulated emission, that is introduced in an alternative derivations of Planck black body radiation law, static model of the universe, which started modern cosmology, quantum statistics of a gas of massive boson, and a critical analysis of foundations of quantum mechanics. The year 2005 was declared as International Year of Physics, and in recognition of Einstein's monumental contribution to the physics in year 1905, describing the revolutionary scientific ideas that have since influenced all of the modern physics here. So we discuss about that has been the fundamental forces in nature. We will discuss that in detail. Next we go for this here. Fundamental forces of nature. So the first fundamental force we have is your gravitational forces. We discuss that. In terms of gravitational forces here, that the gravitational force is the force of mutual attraction between any two body by virtue of their masses. It is universal forces. Every object that experiences this force due to every other object in the universe. All object on the earth, for example, that experiences the force of gravity due to the earth, and in particular the gravity governs the motions of the moon, an artificial satellite around the earth, motion of the earth and planets around the sun, and of course the motion of bodies that falling to the earth. It plays a key role in the large scale phenomena of the universe, such as formations and evolution of stars, galaxies, and the galactic clusters as well. Now we talk about the second force, which is we have to discuss here, and which has been that what we'll have to discuss here has been that has been the second force is electromagnetic force. Electromagnetic forces that we have here. For electromagnetic force that we have is that is what we have to discuss. Please go ahead, and that is about electromagnetic forces we talk about, which is in electromagnetic force is the force between charged particles, and in the similar case when charge are at rest, the force is given by the Coulomb's law, attractive for unlike charges and repulsive for like charges. Charges in motion that produce a magnetic effect and a magnetic field that gives rise to the force on moving charge, where that electric and magnetic effects are in general inseparable, hence the name of electromagnetic force. Like the gravitational forces, that electromagnetic force acts over the large distances and does not need any intervening medium. It is enormously strong compared to gravity, and the electric force that between the two protons, that for example is 10 to the power minus 36 times the gravitational force between them for any fixed distance as well. On the same phase, where the matter as we know that consists of elementary charge constituents like electron and proton, since the electromagnetic forces is so much stronger than the gravitational forces, it dominates all phenomena at atomic and molecular scales. The other two forces, as we shall see, operate only at nuclear scales. Thus, it is mainly the electromagnetic force that governs the structures of atoms and molecules, the dynamic of the chemical reaction, and the mechanical, thermal, and the other properties of material. It underlies the microscopic forces like tension, friction, normal forces, spring force, etc. Gravity is always attractive, while electromagnetic force that can be attractive or repulsive. Another way of putting it at that notes mass that comes only in one variety, that there is no negative mass, but the charge comes in two varieties, positive and negative charge. This is what makes all the differences, and matter is mostly electrically neutral, whereas net charges is zero. Thus, electric force is largely zero and gravitational force dominates terrestrial phenomena. Electric force manifests itself in the atmosphere where the atoms are ionized, and that led to the lightning here. So if we reflect a little that the enormous strength of the electromagnetic forces that compared to the gravity is evident in our daily life. When we hold a book in our hand, we are balancing the gravitational force on the book due to the huge mass of the earth by the normal force that is provided by our hand. The latter is nothing but the net electromagnetic forces that between the charges, that charged constituents of our hand and the book at the surface in contact. If electromagnetic forces were not intrinsically so much stronger than gravity, then the hand of the strongest man would crumble under the weight of the feather. Indeed, to be consistent, and it is in that circumstances we ourselves would crumble under our own weight here. In the same phase, we talk about it, which has been all about that has been another force is about strong nuclear forces. for strong nuclear forces here. For the strong nuclear forces, we talk about it, and so for the same it will be that the strong nuclear forces binds protons and neutrons in the nucleus, and it is evident that without some attractive forces a nucleus will be unstable due to the electric repulsion between its proton here, and on the same phase we talk about it here, and due to the electric repulsion between its proton, this attractive force that cannot be the gravitational since a force of gravity, and that has been is negligible that compared to the electric forces as well, where a new basic forces must therefore is be invoked that the strong nuclear forces is the strongest of all the fundamental forces, about the 100 times that the electromagnetic forces in strength. It is a charge independence and acts equally between the proton and a proton, where a neutron and a neutron, and a proton and a neutron. Its range is, however, extremely small, of about nuclear dimensions 10 to the power minus 15 meter, and it is responsible for the stability of nuclei. The electron, it is must be noted, does not experience this force. Recent developments that have however indicated that the protons and neutrons are built out of still more elementary constituents that are called quarks here. Now we will go ahead for the next that we have to discuss here is being the another forces we discussed here, and that is being the important one. But before starting with this, we discuss about the Satyendranath Bose that has been in 1894 till 1974. Here forward the detail that the contribution that he had made. So we discuss about the rest we'll discuss here in this class only. It is Satyendranath Bose from 1894 to 1974 we have. So we talk about Satyendranath Bose here. That is Satyendranath Bose, born in Calcutta in 1894, is among the great Indian physicists who made a fundamental contribution to the advance of the science in the 20th century. An outstanding that student throughout. Bose started his career in 1916 as a lecturer in physics in Calcutta University. 5 years later, he joined Dhaka University. Here in 1924, he, in a brilliant flash of insight, posed that gave a new derivations of Planck's law, treating radiations as a gas of photons and employing the new statistical method of counting of photon states. As well, he wrote a short paper on the subject and sent it to the Einstein, who immediately recognized its great significance, translated it in German, and forwarded it for publication. And Einstein then applied the same method to the gas of molecules, where the key new conceptual ingredient in Bohr's work was that the particles were regarded as indistinguishable, and a radical departure from the assumptions that underlies the classical Maxwell-Boltzmann statistics. It was soon realized that new Bose-Einstein statistics was applicable to the particles with integral spins, and a new quantum statistics, Fermi-Dirac statistics, was needed for particles with a half-integer spin, satisfying Pauli's exclusion principle, where particles with integer spins are now known as bosons in honor of Bose. An important consequences of Bose-Einstein statistics is that a gas of molecule below and a certain temperature will undergo a phase transition to the state where the large fractions of atoms that populate the same lowest energy satellite, and some 70 years were to pass before the pioneering ideas of Bose, which developed a former further by Einstein and were dramatically confirmed in the observations of a new state of matter in a dilute gas of ultra-cold alkali atom, the Bose-Einstein condensate that we have to discuss here. Now further we'll discuss about the next one, which is about the weak nuclear force, because we had discussed about the strong nuclear forces. So now we have to discuss about the weak nuclear forces here. We discussed about the fourth one, which has been weak nuclear forces. For weak nuclear forces here, the weak nuclear forces that appears only in the certain nuclear processes, that such as beta decay of a nucleus, and in beta decay the nucleus emits an electron and an uncharged particle that called the neutrino. The weak nuclear forces is not as weak as the gravitational forces, but much weaker than the strong nuclear and electromagnetic forces. The range of a weak nuclear forces is exceedingly small, in order of 10 to the power minus 16 meter. Now we'll talk about the fifth forces that we have here, which has been the towards unification of forces. Towards unification of forces. So in terms of towards unification of forces here, we remarked that the unification is as the basic quest in the physics, and the great advances in the physics that often amount to the unifications of the different that we have here, the different physics that we talk about it. And on the same behalf of it, which has been that the theories and the domains that the Newton's unified terrestrial and celestial domains under the common law of the gravitation, with experimental discoveries of the Oersted and Faraday that shows the electric and magnetic phenomena and are in general inseparable. Maxwell unified electromagnetism that and optics with the discovery of the light is an electromagnetic wave here, on the same phase that Einstein attempted to unity gravity and electromagnetism, but could not succeed in this venture. But this did not deter physicists for the zoology pursuing the goal of unification of forces as well. On the same phase that a decade that the recent decades that have been much progress on this front, and the electromagnetic and the weak nuclear forces that have now been unified and are seen as aspects of single electro weak forces. What this unification actually means that cannot be explained here, and attempts that have been and are being that made to be unify the electro weak and strong forces, and even to unify the gravitational force with the rest of the fundamental forces. Many of these ideas that are still speculative and inconclusive, where that summarizes some of the milestones in the progress towards the unification of the forces in the nature as well. We'll talk about the fundamental forces of nature. We go for the same. So fundamental forces of nature. Read a table for it. Name. Then we have your relative strength. Then we have your range. Then operates among. If we go for the first one, that has been the gravitational force. The relative strength is 10 to the power minus 39. Range is infinite. Operates among all objects in the universe. The second is next is your weak nuclear force. Ten to the power minus 13, which is very short subnuclear size. 10 to the power minus 16 meter. Some elementary particles, particularly electron and neutrino. Now we talk about the third one which we have here, which is about electromagnetic force. It has been electromagnetic force, that has been 10 to the power minus 2 infinite, that has been charged particles. Now we talk about strong nuclear force. It has been 1. Short nuclear size, near about 10 to the power minus 15 meter. Nucleons heavier elementary particles. Now we talk about nature of physical laws. And that what we'll have to discuss about the nature of the physical laws in the next coming class. So we're gonna end up with, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than this physics, we had done your sociology and software engineering, we had done your chemistry for class 11th part 1, and for chemistry for class 12 part 1 as well, where in that we had done your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, as well as the conversions, logarithms as well. And we had done your ER diagram, we are dealing with English vocabulary, even though we are dealing with physics interview questions, and we are dealing with general knowledge and important facts about the countries as well. And after talking about that, we are dealing with CBNST, which is in the computer based numerical and statistical technique. We had completed your unit 1, unit 2 and unit 3, and we are dealing with, and in terms of it, quantitative aptitude, we had started with arithmetical ability, in that we had done operations on numbers, SCF and LCM of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, odds and indices, averages, percentage, profit and loss, ratio and proportion. That has been the 11th topic we are dealing with. After talking about that, yes, we had done your reasoning, in that we had done verbal reasoning, where in that general mental ability, in the logic reasoning and non-verbal reasoning, we had done your series analogy, classification, analytical reasoning, mirror image, what image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, and then we have to deal with many more. we had done as well. And after talking about that, we are dealing with that has been the physics part 1. We had started with for the class 11, and chemistry for part 2, which has been the redox reaction we have to start with. And we had started with in terms of your part 1 physics, we had started with chapter 1, which has been the physical words, where in that we had started with what is physics and scope and the excitement of the physics technology and society, fundamental forces in nature of the physical laws as well. In chapter 2 we have to cover up the units and measurement. In that we have to cover up the introduction, the international system of the units, measurements of the length, measurements of mass, measurement of time, accuracy, precision of instruments and errors in the measurement, significant figures, dimensions of the physical world's quantities, and the dimension formulas and the dimensional equation, dimension analysis and application. In the unit 3 we have to cover the motion in a straight line, introduction, positions, path, length and displacement, average velocity and the average speed, instantaneous velocity and the speed, acceleration, kinematic equation of the uniformly accelerated motion and relative the velocity. Unit 4 we have to cover up the portions in a plane, which has been introduction, scalars and vector, multiplication of vectors by real numbers, additions and subtractions of vectors, graphical method, resolutions of the vector as well. In terms of vector additions, analytical methods as well, motion in a plane with a constant acceleration, relative velocity in the two dimensions, projectile motion, uniform circular motion. Unit 5th is your laws of motion, which has been introduction, Aristotle fallacy, the law of the inertia, Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, conservations of momentum, equilibrium of a particle, common forces in mechanics, and then circular motion, solving problems in mechanics as well. In unit 6 we have to cover the work, energy and the power, where we have to cover up here has been introduction, notions of the work and kinetic energy, the work energy theorem, work, kinetic energy, work done by the variable forces, the work energy theorem for the variable forces, the concept of potential energy, the conservation of mechanical energy, the potential energy of a spring, various forms of energy, the law of conservation of energy, power and collision. In terms of it, unit 7 we have to cover up the systems of particles and rotational motion. In that we have to cover up here introduction, center of mass, motion of a center of mass, linear momentum of a system of particles, vector product of the two vectors, angular velocity and its relation, and linear velocity, torque and angular momentum, equilibrium of a rigid body, moment of inertia, theorem of perpendicular and parallel axis, kinematics of rotational motion about the fixed axis, dynamic of the rotational motion about a fixed axis, angular momentum in the case of the rotation about a fixed axis, and of course the rolling motion as well. In terms of unit A, that has been the last unit we'll talk about in this part of it, which is we have to discuss about the gravitation, which is introduction, Kepler's law, universal law of gravitation, the law gravitational constant, acceleration due to the gravity of the earth, acceleration due to the gravity below and above the surface of, gravitational potential energy, escape speeds, earth, satellite energy of the orbiting satellite, geostationary and a polar satellite, and weightlessness as well. So that what we'll have to discuss here. And same cases we're going to end up with. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.